Dear students, today we are going to discuss about the decimal expansion of rational numbers. You have studied about it in ninth standard, first chapter, number system. We know that anyway we can recall the two kinds of decimal expansion of a rational number. The first kind is it is terminating decimal expansion, and the second one non-terminating repeating. These are two kinds. This in this session, we are going to learn how to predict or how to find it without actually dividing or finding it. In ninth standard, we did the division and we found that how to what is the nature of the decimal expansion, whether it is a terminating or a non-terminating repeating. Here, without that, we are doing it. For that, the denominator of the number helps us to find out the methods. Let us understand first the terminating decimal expansion. Once, if we understand that, it is easy to easy to predict or say that how the non-terminate numbers. So we are going to judge the numbers whether they are going to terminate or non-terminate using its denominator. Let us see with this few examples. Here I have taken four decimal numbers and its decimal expansion, if you see that it is terminating. And if you see the first one, 3 decimal places, second one also 3 decimal, and third one has 5 decimal places, and fourth one has 4 decimal places. Now we are going to convert this into a rational format, that is numerator by denominator format. How we can change it? Very easy. How many decimal places are there? That you have to take that number of zeros with 1. So it is 1000. So it is 875 upon 1000. This number we can write as 1512 divided by 3 decimal places, so it is 1000. So 3 zeros, 3 decimal places, it will equal. The next one, it has 5 decimal places, so we can write the number in the 5 zeros, that is 1 lakh. So it is 1764 upon 1 lakh. Next one, we can write here this number. This, how can you write this 4 decimal places? So we can write this 27, and we can write full this number like 2,77,624 divided by 4 decimal places. So 4 zeros, number with 4 zeros, that is 10,000. So we have changed this into a fraction format. What we are going to do is we are going to understand what is the how it look like, or what is the nature of the this rational numbers, its denominator. Okay. Before that, let us understand, if you are taking a number with 0, that is very simple one, number is 10, that is 1 0, that is 10. So we can take it as, when you prime factorize 10, we can write as 2 into 5. When you prime factorize 10 as 2 into 5. But so when you take it as 100, when you take 100, so how can you do it? 100, how can you do it? So 100, actually it is 10 into 10. So it is 10 square. 100 is 10 square. 10 square, already 10, how can we write it? Prime factorize. That is 2 into 5, 10. So that we can write as 12 square. That is when you give the square inside, we can write 2 square into 5 square. Did you watch this? Okay. So if it is 1000, how can you write? 1000, okay, anyway, 1000 we can write as 10 cube, which is nothing but 2 into 5. 10 we can write as 2 into 5 whole cube, which is equal to 2 raised to the power 3 into 5 raised to the power 3. In this manner, we can write it. Okay, so it goes on like that. So now we can write this one. So this is the denominator part, we have to do it. So this we can write as 875 upon 10 cube. This we can write as 1512 divided by upon 10 cube. This is also 1000. This is 1 lakh, so 1764 upon 10 raised to the power 5. Now this one 2,77,624 upon 10 raised to the power 4. Upon 10 raised to the power 4. Okay, so next what we are going to do is just factorize, prime factorize both the numerator and the denominator. So denominator is very easy. So 10 raised to the power 10 we can factorize as 2 into 5. So this we can write as 2 into 5 the whole cube. In the numerator 875. So we can go with 5 because we can divide by 5 because ends with 5. So we can select 5 here. So 1 time, so remaining 3, 37. 7 5s are 35. Remainder 2, 25. 5 times 25. Again 5. We can select again 5. 3 5s are 15. 3 5s are 15. Again 2. 25. 5 5s are 25. Again we can select 5. 5 7s are 35. Okay. So we can write 5 cube into 7, which is equal to 5 cube into 7 divided by 2 cube into 5 cube. 2 cube into 5 cube. So we can erase this. And if you see that after factorizing it, 5 cube and here also 5 cube is there. So we can cancel. What is remaining? 7 upon 2 cube. This we can write as or else we can write as 5 raised to the power 0 also we can include. I'll tell you why I have included that. If a number is terminating, from this one we can understand that its denominator will have, or we can, it is optional. If it is a terminating, the denominator will have either 2. It will have a prime factors 2 or 5, and both a combination of 2 and 5. Did you understand? Either 2 or 5. That one. Another one, 2 and 5, combination of these two numbers. Here 2 is only 2 raised to the power 3 is there. So we can include that 5 raised to the power 0 as for that term. So if it is a number is terminating, from this one we can understand if it is a number is terminating decimal expansion. So it's what is the prime factorization. After if you are getting a number, for example, you are getting this number, we want to check it as a terminating or non-terminating. If it is a terminating, its denominator will contain only the numbers 2 and 5, either 2 or 5 or both a combination. Before that, also we have to prime factorize its numerator also. Okay, numerator after prime factorizing it, if there is any common thing, we have to cancel. Finally, we have to check. And then let us do the next number. Here also it is 10 raised to the power 3. So we can write as 2 into 5 the whole raised to the power 3. This we can prime factorize. 512 ending with 2, so we can select 2 here. So it is 0, 15, 7 times 2 sevens are 14. 2 sevens are 14, then remainder 1, it takes 11. So 11 in 11 5 times. Again 1 we can give it here. So we get here as 6 times it goes. Again we can select 2. In 7 3 times. 1 we can give here. 2 sevens are 14. 2 sevens are 14, remainder 1. Again 8 we can give it here. Again 2 we can select here. So 1 2 is 2, remainder 1. 2 8s are 16, 16 plus 1, 17 we get. So the one remainder 7, remainder is 1 that we can give it here. So 118, 9. We get 2 9s are 18. So when you add these numbers, we 1 plus 8 9, 9 plus 9 18. 18 it is a multiple of 3, so we can divide it by 3. 6 3s are 18, 3 3s are 9. Again by 3, so 21. 21 again by 3, 7 times it goes. So the numerator we can 2 raised to the power 3 into 3 raised to the power 3 into 5 into 7 we get, which is equal to, this we can write as 2 raised to the power 3 into 3 raised to the power 3 into 7 divided by 2 raised to the power 3 into 5 raised to the power 3. 2 raised to the power 3 into 5 raised to the power 3. Here, if you see that 2 raised to the power 3, 2 raised to the power 3 is cancelled. So what is remaining? We can write as, which is equal to 3 raised to the power 3 into 7 divided by 5 raised to the power 3. 2 raised to the power 3 is not, the prime factor 2 is not there, so we can include 2 raised to the power 0. So in this way. But we get, sometimes we get both 5 and 2. Okay. So in this way, we can find out the whether it is a terminating or a non-terminating decimal expansion. I'll give you some practice problems to check whether a number is a prime decimal expansion, whether it is a terminating or non-terminating. Thank you for watching the video.